I want to talk about some interactions and some topics which are linking digital twins much more connected to the urban realm and how they connect to smart cities concept. Actually, it's a very convoluted problem because both of them are ill-defined words and ill-defined terms, as I'm gonna show you during the presentation. And we are I structured the presentation on some recent work that I've been doing with Professor Halvin around ethics and limitations or potentials of the use of these digital twins for particularly for smart cities. So let's start probably by the most complicated thing, which is like building kind of like a common understanding of what we understand by a digital twin. And by a digital twin, actually, it's a two-sided, ill-defined word. On one hand, it's problematic because there are many things which are branded as digital twins, and under the other sense as well, things which are by definition much closer to the actual term or what we can understand as a digital twin. Actually, INCLAD is like a plethora, like a diversity of different things that could be actually in quite legal terms to be considered digital twins. The most basic notion was introduced basically in the 2000s, both from, it's funny how it's interesting how it was coined independently, first of all, from manufacturing by Griffiths in the 2000s, which is the most common like source, and as well within the NASA exploratory probes, manufacturing and life cycle processes. And this is how the digital twin concept was introduced originally. The core idea is mirroring in virtual environments physical assets to improve efficiency and management, the whole life cycle of those virtual assets. And since then, the idea of the digital twin has been evolving and adding new features, new aspects, and being defined in a much more particular ways. In general terms, some level of mirroring has been existing for long periods of time. So actually, we can argue that there has been digital twins for a long time. And depending on the capabilities and features, their level of feedback can be ranging from simple representations of the reality, physical reality. I'm gonna use those terms like physical reality and virtual reality very loosely. So just pardon me in those, but just for the sake of simplification. Representations to informational mirrors, which are able to provide some level of feedback, to more sophisticated predictive, enable this kind of like ideal fully integrated processes in between physical and virtual representations. And underlying all these systems, all these ideas, there is a clear aim for predictability and control. This is probably one of the main goals which were behind them, which is very convoluted due to the complex systems, and it's kind of like unrealistic because of the complexity of the system that they are in principle mirroring. As well, taking into consideration those different types of feedback, we can consider different levels of automation in these processes, which are nonetheless connected or related to the level of capacity of the feedback to inform decisions and affect the physical environment. As a result, we can have degrees of mirroring or sometimes similar to that, which range from what we so call a digital model, but sometimes it's as well branded as a digital twin, when all the flows, all those data flows in between the virtual and the real environments are manual, to some levels of automation that we could have like more particularly or more precisely, we will be talking about digital shadows, or actually when we have those feedback loops of information, we would be having much more precisely defined as digital twins, or a truly digital twin. However, actually, this approach is rather simplistic and rather monolithic approach towards digital twins, because in fact, and this is from an operational point of view and conceptual point of view, as well, is very powerful and very interesting. As well, it depends on which is the purpose and how we use it as any other technology. But in fact, one of the main advantages is that the physical asset, the physical assets can create virtually infinite mirrors of the in the virtual environment. So we can have we can have what if infinite virtual scenarios, which are providing insights about what if alternative physical realities. And this is one of the main advantages of the digital twins. And not only data flow is important, a crucial idea behind these informational feedbacks, but has been arriving in the last version or the last updates regarding the concept of digital twins, relies strongly on latency, speed, bandwidth, capacity of processing. And actually the most advanced ideas, the most sophisticated ideas about digital twins are based on being able to provide real-time feedback seamlessly, high amount of information exchanging between both sides of the process. And this is new frameworks that actually Professor Halvin has been mentioning in some the evolution from 3G to 4G, 6G, NG basically, as well live air, all these kind of new protocols for being able to connect and to share information between different agents, devices, sensors, etc. And as well, it's as well a simplistic view of digital twins, because in fact, what we have behind many of those structures of digital twins is much more sophisticated structured systems. And many digital twins, in fact, are made by aggregation of digital twins of subsystems. So eventually you have a network, or you have a hierarchical dependency on between those different models. And which may have different scopes, different aims, or they may be focused on different tasks of the reality. And at the same time, each of those subsystems are mirrored in a similar manner in the virtual realm. So in the particular case of urban systems, just for being a bit more concrete, we can consider a plethora of subsystems and subsystems, and this is how usually it is conceptualized. So on one hand, we can have the aspect of the scope of domain of those subsystems. This is particularly relevant in cities because we are talking about interconnected subsystems, which exhibit complexity features at the same level in between the interactions of the agents, but as well across different domains. So you have these multidimensional interactions which are going in between across different scales, which would be another important aspect of those different domains or those different subsystems, in between agents and in between different subsystems. Just to summarize, all those different things, even thought they look kind of different, or they may be, for sure, from a sophistication, design, engineering point of view, they are different. All of those, at some point in current literature and in media, are branded as digital twins, from the very basic representations to the more sophisticated ones. Interestingly enough, when we consider this stacking of subsystems, we can see that the complexity increases, particularly when we start to get into the part of the human interaction, when we start just to deal with people. And people are actually involved in many of those, if not in all of those systems. And is when we have been trying to disentangle these application levels and all these challenges and risks which are embedded on trying to mirror in those physical realities into the digital twins. And this is what we have been focusing more on this recent work. So yes, I'm gonna show you a few examples of these different ways of operationalized digital twins across different domains. We can start by infrastructures and geography, because actually territory has been some of the very first domains where actually representation and mirroring have been considered by human beings. We have this actually, it qualifies as a digital twin in some aspects. I don't know if you recognize this thing. This is actually, it's a map. Actually, it's a navigation map from Micronesian islanders in the Pacific. And they represent islands and sea currents, or ocean currents, for being able to navigate from island to island. So actually they operationalize much better than European navigators from the Middle Ages. So It was working till the Second World War, actually, till GIS and other kind of like mapping technologies were able to come. So we have been evolving for sure. We evolve in this informational landscape. And for sure, they are very accessible somehow. They are easier to establish linear quantitative and qualitative connections. More measurement and variables will deliver better data, better representation of the territory. But again, we are missing the people in this aspect. And it's very risky because the use of this socio-technical system can perpetuate this kind of like imbalances in between access to information, use of the space, access to the space. At the end, many of those systems, expert systems like BIM, like building information models, which are kind of like the current standard for designing cities, for designing buildings, are managed by experts, and actually they are managed in a very top-down manner, which is as well connected to something that we were mentioning, I think that yesterday in the dinner, about how you are able to, actually the way that these models, which are supposed to provide like better data, very good pictures, like you have people working on very tiny problems. Nobody would have ever like kind of like a overall holistic view of what you are working on, except maybe the manager. But they have this kind of top-down. So they perpetuate many times this kind of like top-down centralized ways of managing information, which is extremely risky because actually just by modifying the way of operationalize these models could enable different ways of working. Another very common area scope to the use of digital twins is our manufacturing environments. And actually it's very interesting because where the digital twins concept started, it was created, a coin, and it makes quite sense because they are very controlled, well-designed environments with very well-defined tasks. Operations and goals are very well bounded, and as a result, there are situations that they are particularly suitable for control, for command and control, for prediction, and for knowing or trying to understand which is coming. So as they are very straightforward and their goals are very easily aligned with maximizing profiles, so very like economic driven, monetary driven, financial driven goals, they are the ones that actually they are fostering industry 4.0. Actually, most of the times is as well supported by this kind of like frameworks. However, their expected precision in real time can be quite problematic and counterproductive. They try to optimize, and as optimization problems can be hard, they may require large amount of computation, which exceed the amount of data that you need to insert in the system is far beyond what it could feasible from the computational point of view. So you may need like compromises in simplifications. As well, there are like accidents that won't be able to be predicted. So, and as well, more interestingly, they are conceived as closed systems, but they are not closed systems. It's an artificial boundary, because actually they are connected to externalities and depend on supply chains, market conditions, etc. So somehow as well, there are like many aspects of those digital twins that are beyond just the factory environment, control environment. Another common and much more recent application of digital twins has been this aim for creating large-scale, huge replicas of the whole planet. The interesting thing of those digital twins is that they should incorporate as well human activities, because basically human activity has like we are in the Anthropocene, so we know that we are having an impact on the environment. And this is when it has started to become extremely convoluted and complex. They relay, particularly those systems, which are far beyond like the factory environment. They rely on massive and pervasive monitoring and sensing of the environment. And the problem is that just measuring is not necessarily enough, as there may be like measurement ranges, you have confident intervals, you have as well like the way that you define metrics. So you have all these kind of things which are contextualized, and this massive as well accumulation of data per se is as well like rising issues which are connected to big data management. So you have about how you curate data, how you collect data, and as well like about the spurious correlation. So as well you have all these kind of like mathematical artifacts that you may be creating based on this massive process collection and processing and storing of data. As well, like it's even getting worse when you are considering like machine learning and deep learning black boxes that actually even you are not able to interpret what's going on. In a much more connected to human activity, we have, I just gonna mention very briefly two other usual applications of digital twins, which actually are much more connected to or closely related to part of the work that I'm doing here at COS, which are traffic and transportation systems. And actually they are very good examples of how the complexity of human behavior overcomplicates and makes the whole systems far from being predictable and being mechanistic and deterministic. They are based on like the interactions of many agents. So as such, they exhibit complex dynamic systems. So the system is defined, or the system is not only defined by the properties and features of their individual elements. The good thing of these systems actually is they exhibit many of those complex system features. And at the same time, they rely on self-organization, and usually they benefit from diversity and decentralization mechanism. But as well, they are unsuitable for deterministic approaches. This is not how they work, actually, how they operate. So just trying to control them in that fashion is quite undoable. And they are prone to systemic failures. And pretty much the same as well can be said about market systems, like financial systems. They as well like rely on agent-based, like many agents interaction, and they are subject to systemic instabilities. Now we are getting as well to some of those digital twins that they are actually just really centering on people. On one hand, we have simulating and trying to replicate personalized health, like human body functions at different levels, from cellular system whole body functions. And we benefit for sure by simulating those biological and cellular functions for testing treatments to find new correlations and improve our treatments. I mean, this is quite clear with the goal of having these such as systems. And together with the usual potential risk of using massive amount of data that we were mentioning before, we have as well like additional risks, some of the ones that they were included in the presentation, for example, by Marcelo, about like higher risk about like being able to hack bodies or being able to manipulate directly body in a very like a straightforward way. As well, we may be facing issues with regarding like dual use or privacy for sure. Errors here are much more critical in the sense that an input-output reading error here can have like much more crucial errors than just in a Amazon recommender system, to be honest. It's not that crucial. And however, the way that we are, it's unclear how we would be resolving here, for example, conflicts in between when there are disagreements in between which is expected from the digital twin and which is expected or which is observed on the real world. Because basically we're affecting directly human functions. We can expand this idea of the personalized and human or individual digital twins to social systems at a higher scale. But again, we are conflicting with how humans operate. And we process information. We are not unstable, but we are changing our opinions. We are learning. We have language, which is not necessarily like a very well-defined communication method. It doesn't need to be completely defined. Our goals from the beginning, we are empathetic. We are not homo economicus beings that we are just trying to optimize a single optimization function. We are not mechanistic in that way. So we are still having like many cognitive and research challenges dealing with privacy concerns for sure. And particularly integrating all those intangible, not measurable aspects of human life, we can then discuss if we can measure them, if we cannot measure them, how we can conceptualize them, how we can integrate them in these kind of systems. And we are risking the militarization, as you were saying, or like the weaponization of these kind of tools for any given purpose, good or bad or questionable or something in between. Then coming back to cities, now we're going to start with the quotations, with the quotes. For sure, cities sometimes has been conceptualized some of the most complex human beings artifacts created. And probably it's not that far from reality if we consider all this kind of a stacking of systems, because all these kind of like different applications of digital twins, in an individual way, they are summing, and through those interaction networks, summing up into what you could conceptualize as a digital twin of a city, of urban area, country, nation, or the whole planet. We have all these like many systems operating at different levels in cities, in different domains, and there are at the same time interconnected dependencies. And this is where this straightforward approach just on data-driven strategies start to fail, because just capturing more data is not enough. We are missing part of the things which are particularly regarding this part of the stack, if we talk in technological terms. And by definition, cities are weak problems. You may be trying to address one issue, and the moment that you're proposing the solution, already the goal that you define is already changing. So it's kind of like you are chasing always for the impossible kind of thing. And actually is where, and this is this paper that recently Professor Halvin with other colleagues published, which is like incorporating complexity science can be very interesting for adding this much more open-ended networking approach towards not only data-driven, but trying to implement like this much more shifting the focal point of the research. Coming back to how digital twins are structured, all of them, as I was saying, they are conceptualized, they are branded sometimes as digital twins, but actually the most interesting part is here, is when we are having interactions in between reality and the physical world, and particularly the fifth level, the ideal digital twin, where actually everything is automatic, and there's kind of like a feedback loop in between them. And this is where data may become insufficient, and including complexity is needed. Just machine learning and AI is not sufficient because they are opaque and they are not operating in the same level of knowledge of people, and we will be lacking anyhow qualitative aspects of life. And then we will start to colliding with human rights, with human dignity, which is the funny thing but even we are questioning these things these days with very simple data center aspects that the European Commission was mentioning yesterday. And is in this level of automating, where it starts to be like extremely interesting, the whole thing interesting, is inspiring and threatening at the same time, because by introducing the metaverse, actually there is like a very interesting thing on the physical world, that we have like many uncertainties of how to measure things. But when we start to commodify, transferring or tokenize everything to the metaverse, actually every single thing, every single aspect of our life can be measured in a much more efficient way. Okay, you can like digitize human behavior in a much more efficient way. And this is where it's somehow like making easier this kind of like gap in between physical world and digitization, that somehow we are, okay, as we cannot like address physical reality, we can just move as many things as we can to the digital realm, such a way that we can measure them in a much more efficient way. And by this metaverse actually, or metaverse augmented reality, we can have actually close the loop, and close the looping from the virtual reality to the physical realm. And by closing the loop, because basically we have very clear idea how the physical realm is transferring data and informing the virtual realm, but the most ideal version of the digital twins is actually to create virtual entities which are able to actuate and modify the physical environment. By now, it's very far from being realistic, but actually we see that those visions of the metaverse and the augmented reality are actually able to modify reality or accommodate reality to whatever is created in the virtual environment. And is when we can start to have some issues regarding like social divides and access to the reality and the right to the city. Just to wrapping up these aspects about the smart city, as well as like a very convoluted term about and how it's inserting. Actually, you're gonna see that many of the things that we were mentioning about the digital twin actually is already integrated in the smart cities, because they are very technological driven and they are technocratic, top down, and actually they have been very oriented by corporations. I mean, they have like a very financial cooperative aspect in their mind, and their close ecosystems. And again, that need to be expanded in those same aspects. Actually, we're saying that those much more sophisticated, people-centered digital twins should address as well. They cannot be only data-driven and looking for just pure optimization of aspects. Because this is colliding with one thing which is connected to Lefebvre. I mean, it's very old discussion, but actually who has the right to the city, who is deciding the city, but as well who has the right to the smart city. And creating these technological divides and those like top-down systems are not helping. So basically we are coupling digital twins with smart cities. Basically, digital twins right now are becoming the last iteration, the kind of like the last reformulation of smart cities. And again, they are facing issues with limits of predictability, limits of coupling, how much you can transfer from the physical world to the real, to the digital world. And eventually you have problems of data and computing limitations, because a city is not a computer. It's not deterministic. It's much more than that. And there are like other qualities that should be as well included. And in our Turing machines, they are not designed that way. So we have tons of high quality data. We have good models, high capacity for connecting both worlds. We may be articulating participatory processes as well for trying just to ease a bit the process. But still, we will have like many issues in trying to leverage both aspects about like policy, legitimacy, political authority, flow participation, just for shielding like other kind of like interest. So one thing that actually we're proposing, and with that, I just I'm gonna throw some alternatives. How we can conceptualize or reconceptualize this idea about having like open-ended planning process. I mean, planning processes not only for cities, just in general, like not having like in mind like a pure optimization, being an optimization problem, like from an engineering point of view. And we have been working on those aspects, which is, for example, things that Sachit was covering this morning as well, like technology as an enabler of facilitator for trying to create discussion and creating like common goods across people. And digital twins are much more interesting for their exploratory capabilities than for being like predictive deterministic machines. We are very good for exploring, for probing, and for predictive. And somehow that's why sometimes we have been considering like making the use of these like sandboxes or these like what if exploratory scenarios we can really perform this kind of testing in a sandbox fashion, like in a safer way, cheaper way, but as well they can enable this kind of like exploration and innovation in much more operational way. And with that, I'm finishing with Winston Churchill. Actually, Rohit was mentioning me that I should replace that by James Gibson, right? Because he was mentioning something as well very similar from the Gestalt and from the cognitive point of view, but as you mentioned, it was diagonal.
Wonderful presentation. All right, so we all have Have you all played SimCity once?
Yes.
Yeah. Okay, but at least familiar with the concept? You know, there's the city running on your computer rather than the computer running the city. So I see the point that, okay, the idea is not to make one category more efficient, or, you know, any sort of efficiency maximization or variety maximization or any sort of those logics. But what do you see are the potentials when we set, say, a variety of parameters? Just as a simulation. Let's run the simulation rather than the city. Let's set a variety of parameters that we all democratically agree to. So we all want a little bit more greenery. We all want to have maybe more water in the city, open things. But we also want less crime. And so let's set democratically those efficiency parameters in a variety of ways. Sounds very beautiful. Everybody can contribute. We make it an electoral process. What are the potentials for having a look at how those kind of, because they are all in a way efficiency maximization,
yes,
functions. But would it be possible, and that I'm really curious about, to play them out in parallel and see what sort of unintended consequences, if we want to achieve those based on the simulated city we have, what kind of unintended consequences we might result? Because I'm wondering whether, if we have a set of a variety of different functions that we want to achieve, and that's the whole purpose of why we have politics, right? We want to achieve certain changes in our environment. What are then kind of, you see what I mean?
Yes. This is an old history. Actually, it's coming from the early days of urban simulation. It's like, but it's kind of a trap somehow, as well as like a cognitive trap. Just by adding like more data and being able to measure many more times, you are able to get like better models. At some point, okay, that's a valid argument, but it's not only that. It's a trap first of all, or it can be considered like a cognitive trap because somehow first of all, the way that you are collecting data and the way that you are processing the data cannot be like actually addressing the problem as you are envisioning. So that's why, and this is beyond. I mean, it's kind of like it's surrounding the digital twin. It's not in the digital twin, but not just by ignoring that, you are making better the digital twin by itself. This kind of like subsistence or like partial operating these days, what companies, because actually it's very interesting, they are like cooperative software solutions that they offer to cities. They are promising to optimize the small aspects of the city, or very particular aspect like waste disposal, water system, electric grids, traffic management, and they want to optimize those small things. And probably for those very bounded issues, you can disregard at some extreme the externalities, or it's even legit. However, when you start just to scale it up much more to higher levels of disaggregation of data, first of all, we are lacking, and this is what we were mentioning part of those, like not only data driven, we are lacking like conceptualization of how those different elements are connected. We are lacking information of that. So how do you dare to model some of those interactions at different levels? That's why, for example, with policy, with crime, is a pretty well-known case that the way that actually all those policing systems are designed, first of all, they are opaque, just without going even into deeper consideration. They are quite opaque. The way that they are considering the data collection and the kind of goals optimization is kind of like a recursive loop that they are just focusing on a type of crime, on a type of like interactions. You are just over policing areas that they were already bad. So at the end, it's this kind of like cognitive trap that you are creating. But because as well they are driven by this very perverse financial, corporative, or even politics incentives. The interesting thing of actually being able to have like a higher not simulation, like model of the city, actually is not for optimizing. It's not for optimizing. First of all, interacting or intervening on the real physical environment is extremely expensive. It's extremely hard, and it takes a lot of time. Actually, the difference they were saying once, the difference between architects and planners, like a planner design one thing that won't see during his or her lifetime, because it's very long, kind of long process. However, the value of these systems is being able to explore in a much more human or like cognitively accessible way all those different things, and this is one value that you have. However, you cannot be either falling on the cognitive trap of just being bounded by these like very poor models or poor conceptualization of reality, because you need like more theories, you need like more knowledge about how different things are interacting. Probably you need like better measurements or better, like you were posting yesterday one very funny thing about like our social human formulas, mathematical constructs are far simpler than our physics, mathing that, and this is the kind of thing that they are usually not considered on these data-driven approaches, because we are just expecting, but just by pulling a bunch of data on those systems, somehow they will rise some kind of like some kind of things. So just for replying, for summarizing your question, for small things, it's useful, but for higher levels, we are lacking theory, we are lacking knowledge for being able to just being dragged by the fascination of the things. Like cognitively, we are very fascinated for predicting the future, which is as well like a cognitive trap. And we're like, oh, I have like a simple solution, a simple forecasting. I love that. And this is very easy to sell. When you start to get in like much more convoluted like problem, and the problems start to be like very problematic or very like complex, it stops being like cognitively cognitively accessible somehow. However, I think that this, they have, that's why I was just trying to finish them by, they have value just for being able to raise awareness of issues that maybe you were not. And this is very interesting. Actually, this, like, instead of using them as predictive and giving you an answer, they should be used mostly for asking questions. Like, you play with them, and then you would be probably like change your mind. And actually, it's very interesting how people maybe change their opinions or their visions of issues in the city, in the country, and learn from those tools.
Yeah, thanks. Yeah, that's an amazing topic. I'm a bit puzzled by the term twin.
Twin.
And here's why. My twin would be second person. If I had a twin,
yes.
We were twins, we were two.
Yes.
Right. So I get the idea of the digital twin. So it's the analog and the digital. And they are two, and with all the errors and all the explanation you've given. But I'm still a bit puzzled because the twin would be a second entity. And I was wondering if maybe because of its clandestine nature, we're not necessarily aware, unless building the architecture, not necessarily aware of us having a digital twin, like the customer lifetime value and the scores and whatever. So how do we get the clandestine dimension into the terminological concept? That's the question I asked myself when I listened to you, because I think twin is too much of an explicit second entity. Google, maybe it's a Google. Like, we don't know if it's the real Andre or not. Maybe it's a Google. So
I don't even know.
So that's I'm just giving you a state of my reflection because
I mean, you can call it ghost actually because it's like, or it's like, because it's most, well, first of, but this is like operating as well, like a different level. Well, words are kind of like catchy, and probably when the term was coined, like in, let's see, like 20 years ago, probably they weren't thinking of all this kind of like, it was much simpler. It's like, I want to have kind of like a simulation of how this thing gonna be working. I have many parts, and when I launch one of those probes, for example, to Mars or to Pluto, they're gonna be operating for 30 or more years. So I want to have kind of like an idea of how it can be evolving. That's it. But we have to stick to the term, and we love to be stuck to terms somehow. Yeah. So I think the problem of the things, but this is as well, I think that it's like an ethic and normative problem, because on probably on internet we have many companies have digital doubles or digital ghosts of ourselves, and probably they are able to try to replicate our behavior, which is problematic because maybe you are not aware. I think that we were talking as well, like just say about like being aware of manipulation, and here is something the same, because it's very different if you are creating your own and you are programming, or you are like consciously asking for, I want to have like a digital double for example, this very controversial thing that sometimes we have been rising about, having like kind of like having a delegate, a political digital double who is taking decisions for ourselves for voting. You can be, I'm pretty sure that there will be people like, hey, I want to have that as a product, and you commission that. You can consider that. It's much more problematic, the thing when you are not aware of those digital twins. Companies or third parties are taking decisions for the thing here. The things like, which is the goal of having that digital twin, of predicting and manipulating yourselves. However, this is very interesting because of their own nature and limitation of the digital twin. It's very interesting because somehow they're as well trapped in this logic of like, they are not good for predicting human behavior. And that's why you are having issues with the bank. Because your digital twin, that your bank, our bank, have a digital twin of ourselves regarding our financial behavior. When we are getting out of the usual expected behavior, they start to bother you. Like, I mean, I blocked your car because you haven't been behaving as it was expected. So somehow as well, the interesting thing of those ghosts or doubles are they are trapped within this logic of like, humans are not predictable per se. And actually, when you see many of the digital twins, actually, I would say that they are like on e-stores like Amazon, like trying just to predict like how people are gonna be behaving. Probably you have kind of like, actually, yeah, there is this thing like in marketing, or like when you're designing a product, you design like this kind of like persona analysis. So you try, and probably Amazon or many of those e-commerce websites, you are registering, so they collect your behavior information, and they're just trying to predict what's going to be your next purchase, right? But sometimes the things that we have, right? But that's why I was saying like it's mostly a regulatory, probably a regulatory legal issue. Like somehow you are permitting this in this particular case because you are you are signing, you're accepting conditions that you haven't read. That's the first thing that we need to take into account. But then they are like playing with you, with your digital, with your digital double, even if you are not aware of.
Yeah, just sorry to interrupt you, but aren't we then just fooling ourselves? And I very much like what Peter says here. Aren't we just fooling ourselves to say, well, you know, we like to predict, but maybe let's, you know, not steer. I think it's the only reason why we want to predict this, because in the hope that we can steer.
Not necessarily, I think. No, maybe yes. In some cases, yes, but I wouldn't say that you are expecting to steer.
No, it's just curiosity.
No, either. You want to predict, but not to steer.
From a business perspective, because at the end it's about money. At least that's how I look at most of the things. Yes, the next purchase, that's very important. But what's really interesting is what is the core concept, and it's pricing, the willingness to pay. So what is the willingness to pay of you and you for this specific product? Because we go from equal prices, the principle of equality, to personalized and dynamic prices. So that's what the prediction model, at least in my business-driven perspective, is all about: maximizing revenue and profit. And if I know that income situation, buying behavior, preferences, all of that, I can make a better calculation on the individual willingness to pay. And that's where the money is.
But
so that's the prediction.
I would, it's a story. You may be then trying to readjust for matching better, which is expected. But maybe you are not expecting that the behavior, maybe it's the other way around. Is a manager who is steering their behavior for trying to match the expected behavior.
Am I going to the astrologer? This is an interesting question. Am I going to the astrologer to know the future, or with the hope that if I know the future, I can better prepare for it? Because what is the added value of knowing the future if it's unavoidable and the only thing we can do is to take it in the face anyways?
I think that both
depends on the ontological foundation, what you think about the future.
I think that both are possible.
It always does, doesn't it?
Both are possible. Both are possible. Oh, future probably is kind of like you have a range of possibilities at the end, so it's not like it's going to happen like that. But probably both things, like how much is the productivity that you want to take on? Like you really want to steer, you want just to be prepared, you want to match the expectations just for maximizing your own outcome, your own through output.
Well, really what Peter says, right? It depends on whether you believe that you can influence it or not, right? That's the ontological basis of your expectation of knowing about the future.
Oh.
I think there's no further questions, so we'll wrap up this session. Thank you, Javier.
Thank you so much.
Can you show your first slide again?
Yes. Which one? This one? Or which
Some
one?
colorful thing.
This one. This one? Okay.
All right. Yeah. So I would really like to thank all of you for participating in this wonderful twin workshop. We've been pretty
Double workshop.
Now, it started with the situation where half of the people we asked for participation were available in one time slot and the others in the other. And so finally we decided we wanted to be inclusive. And the only way to be inclusive was basically to have two workshops. And then eventually we decided to call them twin workshops, also because partially it's about digital twins, so kind of had a double meaning. Event, there were a lot of last-minute cancellations. That means the twin is not doing so good, not as good as we expected, as compared to the reality we had in mind. Perhaps that has something to tell us. Now, here's one. We cannot solve our problems with the same thinking that created them. And so now we have a new approach, which is the digital twin approach. And again, it creates new problems, obviously. And among them, it's that we may get trapped in something that could be called the digital matrix. You know, Elon Musk, again, you know, that's the person I was missing basically in all our talks, I guess. He has been warning us of the possibility that we could be living in a simulation. And perhaps we haven't always done so, but we may end up living in a simulation, as we now see, with all those digital twins interfering with our daily lives increasingly so. And he's been warning of the matrix. I think he was not very explicit because it was basically perhaps something like a military secret at that time, but at least he made us aware of those issues that were in the air. And now we have to talk about it because it doesn't work as well as they hoped. In fact, the entire issue is that we engage in a data-driven world, AI controlled, as they're now trying to do that, basically. We know that what AI is doing is based on previous data. That means, in a sense, it continues the old world, while we know that the solutions of the past don't work for our future. That's why we talk about an unsustainable world. And unsustainable basically means it's not future-proof. The only one thing that we really know about the future is that it will be different from the past. The current system won't be around much longer because it's not sustainable. But here AI is not necessarily going to help us because it's restricted to the data of the past, while apparently we need an entirely new solution and approach. And perhaps that's why we should think another time about a very old quote, which is actually from the Bible, Exodus 24. It's part of the heritage that Jews, Christians, and Muslims share. And it says, "You shall not make yourself an image of God or the heavens or earth or waters," oceans, I guess. And perhaps but the question is, what does that tell us in modern times? And perhaps we should not try to create a too detailed picture of the world because it would be restricting ourselves too much. It would eliminate all the freedoms that we need to be creative and innovative and co-create, in fact, the future. And that is something that perhaps we need to think about. How do we get back freedom in that data-driven world? And the twin term is actually aiming to create a digital duplicate as realistic as possible, as identical as possible, to the extent that some people would think, okay, we could actually replace physical human beings by a digital representative. Some people want to learn how to upload brain content to the cloud. And they have this idea that in principle, we could live without a body as a digital being. So the digital twin would basically eventually replace us. And that is an idea that some people would relate to transcendence, but I think it may be a terrible misinterpretation, may end as the biggest disaster of human history altogether. So I would really caution to go into this direction. And that's why we need to have a discussion about the opportunities and threats and limitations of digital twins.